So hello everyone, let's talk about another problem which is lowest common ancestor of a binary tree. The problem description goes as given a binary tree BST, find the lowest common ancestor LCA. Node of the two given nodes in the BST. Okay, according to the definition of LCA, basically this is the definition of LCA. What is LCA? So let's try to understand this problem. So first of all, we need to understand what is LCA. So I have make a video on LCA. So let's try to recap it. What is LCA? Suppose we have a binary tree. Let's make a tree. 4, 5, 5, 6, 7, 8. Okay, so this is the binary tree. Let's suppose it should be 20, 21. Yep. So what is LCA? So first of all, LCA is basically what we can say the mm, basically it's nothing but the basically uh what is the root, basically we can say what is the it is the root of two different nodes. uh let's take an example, try to understand this. Okay, so if we have to find LC of two nodes, suppose this is our one node, this is our two node. So LCA of 21 and 9. So if we traverse, what is the first root node which combine both the nodes? So this is the first node, this is the second node. So if we track it, so we say that the node 3 basically contains these two nodes. Okay, and one node 1 is also containing, but we have to find the least one. So the least one is 3. So this is what we call LC. Let's take another example. Okay, let's take another example. Suppose we have to find, let's make some more 49, 56. Okay, so let's suppose this is our tree. Okay, so we have to find LCA of 5 and 56. So now we can see the LCA of 5 and 56 will be 1. But how? But how computer sees? So we have to found LCA. So how can we find out LCA? So basically first in question we have given that root node along with the two nodes which we have to find the LCA of. Okay, so if we traverse left side and right side of the tree, okay, left side and right side of the tree we found node. Okay, suppose this node is present left side of the tree and this node is present right side of this tree. Okay, 56 node is present right side of the tree. Now again we come back to that node, and if we found that this node 1 is basically common in both the nodes, then we will return LCA of nodes is 1. Okay, LCA of node 5 and 56 will be 1. Simple. Okay, let's try to understand with code also. So let me write it code. So first of all, we have to the three things which are given is basically root node and node P, which is also called as node 1, node 2. Okay, so the base condition, what is the first of all base condition? Base base condition of root tree, and here we have to return root. Okay, so first of all, what is the base condition? If our root is equal to null, it's simple. It's basically pretty much same in most of the question. So we will return null. Okay, now what we have to say? Now the second condition. Now the second condition is basically if we found any value which is equal to node P or node Q, okay, in our from our root. Suppose, let's see in whiteboard, suppose we have to find, yep, we have to find node 5. So if we are traversing from left side from our root node, then we will find that this root node is present. Okay, so now we have to pass this root node till that part. Okay, so if we found our root node which is root value which is equal to root value, or which is equal to, let me, which is also equal to q dot value. Okay, then we will return root here, so that we can say our root node is present at that uh, the value which we are finding from P and Q, that node is present at that part. Okay, simple. So now the next part will be, we have to traverse left part and the right part. So for that we make we again call the same function, lowest common ancestor, and again we have to part root left side and the same node P and Q. Okay, same with right part of the tree, ancestor, which is basically root right P and Q. Simple. So what will this thing gonna do is basically return me a root which will be present in the left. If my node basically P and Q which is uh, present in left subtree or right subtree, it will return me a node which is a part of lowest common ancestor. Okay, so let's make a node here, tree node. Okay, so this is the LCA, let's name this LCA1. Okay, same thing which we gonna do if we get a node from the right side, so we have to keep track of that also. So LCA2 which is equal to this part. Okay, simple. Now the condition, if LCA is not equal to, how this gonna look like, is not equal to null, and what we can say, LCA2 is also not equal to null, then in that case we have to return in that case what we have to return, we have to return root, return root. Okay, the another case which is, suppose, let me open my whiteboard also. So whiteboard is, yeah, so as we can see, suppose if we have to find a root node, let me rub this. Suppose if we have to find a root node which is on the same side, suppose we have to find a root node of this side, so only the left part of this tree will return both uh that is LCA1 will be not equal to null. Okay, not equal to null. Okay, but from the right side of the tree, we will get an answer for LCA2, which will equal to null. So what is the lowest common ancestor from these two? If we go upwards, we can say lowest common ancestor of both of these node is basically 2. Okay, so now we will see how this would work. Suppose if it is present on the left side only, which is not equal to null, then we will return what we have to return. We have to return true. Okay, not true, basically LCA1. Okay, else what we have to return? Else we have to return LCA2. Simple. LCA2. If we found both the nodes are present, or if a single node is present on the left side. So let's try to run this code. We have done a spelling mistake. Lowest common ancestor cannot. Yep, yeah. Lowest WSC, lowest common ancestor. Yep, it is saved. Let's try example test case also. So yep, it is same. So basically it same pretty much about that. We does not have to take care of anything, but we have to traverse the left subtree and the right subtree for that. Okay, so thank you.